Hi guys. Alright, so here are some notes on 11.2 Arithmetic Series. And now this is continuing from looking at the arithmetic sequence. The sequence was when you just had a list, and that's of the ordered numbers. A series is then when you take those numbers in the list and you make a sum out of them. So remember I told you there are going to be a lot of S words going on. So series and sum are always going to go together. So for instance, if we have a sequence 4, 7, 10, 13, 16, it's just a list of numbers. The series that would go with that sequence is 4 plus 7 plus 10 plus 13 plus 16. So it's when you add them all together. So an arithmetic series are the sums of the arithmetic sequences. Whew, okay. Just don't try and say that 3 times fast. So we can find the entire sum of the arithmetic series, or sometimes we just want to find a partial sum. A partial sum is when you're only finding a few terms, the sum of a few terms. So for example, here I have a series, and so I've got 1 plus 10 plus 19 plus 28 dot 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 dot. So the first partial sum is just the first term right here. The second partial sum is where you take the sum of the next two terms, so that's going to be the 1 plus 10. Third partial sum is then when you take the first three terms and add them together, and etc., etc. So when you get to the end, then you have the full sum of your series. We say right here that this would be the seventh partial sum. Is how we would refer to it that way. And notice you have the capital S represents the sum as opposed to the lowercase a, which was when you're just talking about what place are you in line in that list. So if you remember back to when we did the superstairs, and I know I keep going back to that, and we tried to look at, as you were looking, so we're going to look at this table here, as we looked at each step, each stair, how many steps you would take on that stair. So it was 2, 4, 6, 8. It went up by 2s for each stair. And I talked about if you take those numbers, so we're going to take the first 8 terms, and that gave you 16 steps, and then we were going to reverse it and do 16, 14, 12 on down. And if you add both columns together, what you get is this constant sum. And so this is how we're going to come up with our formula for being able to find the sum of a series. So notice I have a constant sum of 18 8 times. But by doing that, we've actually doubled how many times we've added our steps. So then we have to divide by 2, and that gives us the true sum of those first 8 steps. So you have over here the 8th partial sum is 8 over 2, the first term plus the last term, and that gave us a sum of 72. So we can formalize that. So the nth partial sum is going to be S sub n, and that's going to equal the n, however many terms you have, divided by 2, and then just the first term plus the last one. Now this formula is great when you happen to know the first and the last term, but you don't always know that. So what happens is sometimes you know your a sub 1 and you know your difference, but you don't know the last term because it just gives you the first couple terms. Well, this is what you would do then. You take your S sub n, and we start off with n over 2, and we're going to have our a sub 1. But now I don't know my a sub n. So what we're going to do is we're going to substitute in here. Remember, we have our formula for a sequence, whereas a sub n equals a sub 1 plus, this is like your linear equation. So we're going to substitute that in here, plus d times n minus 1. And then when we go through and simplify this out, notice that you have 2 a sub 1's, and that's how we get this formula down here. So the nth partial sum, so you have two major formulas. You have the one for when you know the first and the last term. So you just take their sum, divide it by 2 and multiply it by however many there are. But when you don't know that last term, then you take twice the first term plus your d times n minus 1. Okay? So the key is, again, it's like a scavenger hunt. Always identify what you have and what you need to find. So let's do a couple problems. So this first example says, find S sub n and then the sum of the first 40 terms. So let's look at what we have. We have a sub 1, and because I have several terms, I can figure out that my d is going to be a -3, and I don't have a sub n. So we can figure out that our S sub n, so it's just a generic n, is going to be n over 2, and I'm going to use the second formula because I don't know a sub n. So I have 2 times my first term, 2 times 80, and it's going to be minus 3 times n minus 1. And we're going to then simplify this out. So this will simplify out to n over 2. I have 160 minus 3n inside, well, I'm going to do it over here. N over 2, 160 minus 3n plus 3, which gives me 163 minus 3n. And that would be a general formula for the nth partial sum. So if I wanted to find the first 40 terms, rather than sitting there adding them, you know, this number plus this number, 2 plus 4 plus 6 plus 8, which is what you guys did with the superstairs, we can apply this formula. So n now is 40, so we can plug in 40 over 2, 163 minus 3 times 40, which is 120. So 20 times your, what was this, 43 comes to be 860. Okay? And of course, if we're going to be talking sums and having to write out something plus something plus something, that can be very tedious. So in math, we always come up with a nice shorthand way of doing things, symbols. So what we have here is the Greek letter sigma, which represents your sum, your S sub n. And the way this is going to work is you have little key terms here. So n equals 1, what goes underneath your sigma is saying this is the starting place, okay? We call it, you don't have to worry too much, index of summation. Yes, that's the official term, but it's really just telling you we're going to start when n is 1, and we're going to go until n is 10, and we're going to substitute in those numbers and then add them all together. So it works kind of like this. Now this is really the long way to do it. There's shorter ways that I'll show you in a second. So if n is 1, what we have is 2 times 1 minus 1. So 2 minus 1 is 1. If n is 2, then we have 2 times 2 minus 1, which is 4 minus 1, which is 3. If n is 3, we have 2 times 3 minus 1. You can see how this would be really tedious. 6 minus 1 is 5. And then we would keep going, but the idea is if we're summing, we're going to then add all of these terms together. So far I have 5, 6, 7, 8. So S sub 3, the sum of the first 3 terms would be 8. Now, I'm not going to sit there and plug in n equals 4 and n equals 5 because that's just time consuming. We have, this is just a shorthand way of saying find S sub 10. Okay, but we have a formula to find S sub 10. Our formula for S sub 10 is S sub 10 equals 10 divided by 2. My first term, which is when n is 1, so this is going to be like finding your A sub 1, which we know is 1, plus we want to find A sub 10, because that's going to go in this last place, A sub 10. So when you plug in n is 10, we'd have 2 times 10, 20 minus 1, which is 19. So then we can just go 5 times 20, which is 100. Okay? So again, how do you do this? This is just a shorthand way of saying it's like a repeated substitution, plug in n as 1, plug in n as 2, plug in n as 3, and then you're going to add all those terms together, and that gives you that partial sum. If you want to find the whole spiel, the whole sum, you use your formula. You find your a sub 1, which is plugging in n equals 1. You find your a sub n, which is plugging in the last term when n is 10. And then you have your n over 2. Okay, so here's another series. We want to find the first three terms of the series. So what we're going to do is plug in n is 1. So again, 3 times 1 minus 2 is just 1. Then we plug in n is 2. So 3 times 2, 6 minus 2 is going to be 4. And then we're going to plug in when n is 3, and that's going to give us 9 minus 2, which is 7. So those are the first three terms of your series. The last term is when n is going to be 25. So it's just 3 times 25 minus 2, so that's going to be, what, 73? And here, if we want to evaluate the series, what that's asking for is s sub 25. So that means n is 25. So we have 25 divided by 2. The first term, which is when n was 1, plus the last term, that's when n was 25. And so we have here the final answer, I do have it worked out, is going to be 925. Okay, so you have this sigma notation, which is just a shorthand way of saying your s sub n. So n equals wherever you want to start, and then it goes till when you want to finish, and then your, whatever your equation is, your function of n would go here. Okay. So we're going to try a few harder problems, just so you can see how it really can be like a scavenger hunt. So we're going to want to find the first three terms of the arithmetic sequence. Well, to find the first three terms, I need to know what the common difference is, because I already know the first term, but I'm trying to find the next two terms that would come after it. So notice I don't know d, but I also don't know n. So we're going to have to do a little scavenger hunt. So before we do that, let's look at the formulas that we have. We have a sub n, this is our sequence formula, which is a sub 1 plus d times n minus 1. I recommend every time you guys do a homework, you write them down, because you then won't have to worry about memorizing them. You'll have used them so much. Then you have your s sub n, this is your sum formula for the sum of the series. That's your n over 2, a sub 1 plus a sub n. And that has a second version, n over 2 times a sub 1 plus d times n minus 1. That's the one when you don't know your a sub n. Okay, so which formula do we want to get to? Well, we're going to find n first, because based on the given information, I don't know d and n. So d and n both appear here, d and n both appear here. So if I use this middle formula, I only have one unknown, and that's my n. So we're going to use s sub n, which we know is 2247, and that equals our n, which we don't know, over 2 times a sub 1 plus a sub n. And so multiplying both sides by 2 will allow me to cancel this 2, so that I have 4494. 4494 equals n times 214, and when I divide both sides by 214, we find out that we get n equals 21. So there's 21 terms in this series that we're going to be looking at, in this sequence actually. Okay, so now that I know n, I can start to find d. You have choices whichever equation you want to go to. I think this first one might be a little more simple, so I'm going to go to that one. Alright, so I'm going to do that one over here. So let's see how this works. So a sub n, well, we know a sub n. A sub n is 197 equals a sub 1, which is 17, plus d, which we don't know, times our n minus 1, which is going to be 20. So working this out gives me 180 equals 20 times D. So D turns out to be 9. So now that I know what D is, I can make my list. I know I have 17, then add 9, that gives me 26, then add 9 gives me 35, and voila, you have your first 3 terms. Okay. And again, that's a sequence, which means you're just looking for a list. Now we're looking for, in this second one, the sum of a series. And so let's see what we have. We have a sub 1, we know, is 34. We know that our common difference is a negative 4. We do not know n, but we do know that a sub n, the very last term, is 2, because there's no dot, dot, dot after it. Okay, so what can we do with that? We are going to start looking. We're going to look to find our n first. So to find our n first, we're going to use our a sub n formula. So we know that a sub n, which is 2, equals a sub 1, plus our d, which is a negative 4, times n minus 1. So notice when I plug those in, I only have the one unknown. That means I can solve for n. So let's simplify this out. We have 34 minus 4n plus 4, so that's 38 minus 4n equals 2. So negative 36 equals a negative 4n. We get that n equals 9. Okay, so how does that help me? Well, now that I know that n is 9, I can find my sum. So I'm finding the 9th partial sum, because remember that n is 9. So we have 9 divided by 2, a sub 1, which is 34, plus a sub n, which is 2. And when you work that out, you get a lovely 162. Okay, I want to do one example that I know comes up in your homework. It's number 15, where k does not start at 1, but it starts at 3, and show you sort of a shortcut for how you might want to do a problem, because you might think that you have to go through and find k is 3, k is 4, k is 5, k is 6, k is 7, and then add all those together. So you would add all the results, and that would give you that particular sum. But you can actually remember that since these are kind of like linear equations, there is a shortcut. We know that between 3 and 7, 1, 2, 3, 4, 5, you have 5 terms here. Okay, so we're actually going to be finding a 5th partial sum, and that means n is going to be the 5. So we have 5 over 2, and we're still going to find our first term, that's the only one we need, and our last term. So the first term is when k is 3, so that's going to be 3 times 3 plus 4, so that's going to be 13. And we'll find when k is 7, so that's 3 times 7, 21, plus 4, which is 25. So then we have for ourselves 5 halves times 38, and that is going to give you a lovely total of 95. So it's a little bit shorter than sitting there finding each individual term, which you are more than welcome to do, but this is just a way of getting there faster. Okay? And good luck. I have quite a few answers posted in a pencast going over the solution, so if you have trouble, help each other out or use the iPads and look at the pencast.